So now we're going to take our lesson from yesterday on factoring our trinomials, and we're going to now use our zero product property to go ahead and solve to find our solutions. So we're going to take all those answers that we got before, and we're just going to take them one step farther by setting them equal to 0 and then solving them. So we're going to start by factoring it just like we did yesterday. So I know my first term is just going to be m. I have a positive and a positive, so that means they were both addition. I think about my 9. What could I multiply to get 9? Well, I could do 3 times 3, or 1 and 9. Which of those is going to add to give me 10? Well, 1 and 9 are going to be my options. So that means I have a 1 or a 9 for an answer. So that's what we did yesterday. Now we're going to take it one step farther. Since the equation is equal to 0, we're going to use our zero product property, meaning if either one of those equals 0, my answer is going to equal 0. So I'm going to go ahead and set each one of them equal to 0 and solve them. So I'd subtract my 1 and get m is negative 1. I'd subtract my 9 and get m is equal to negative 9. So those are my two options that would make this solution have a solution of 0. So let's check and see if it actually works. So let's plug in negative 1 in for m. So I have negative 1 squared plus 10 times negative 1 plus 9, and we want it to equal 0. Well, negative 1 squared is 1, and 10 and negative 1 is negative 10, and 9. 1 plus negative 10 plus 9 really is equal to 0. So it worked. Now let's check it with the other solution. The whole idea behind a quadratic equation, something with a squared term, is that it's going to have two solutions that work. So let's check again. Let's put in negative 9 instead. Negative 9 squared is 81. 10 times negative 9 is negative 90 plus 9. 81 and 9 is 90 plus negative 90 really is 0. So both solutions really did work. So let's do our next one. You notice this one, all my terms aren't on the same side of the equation, so I need to move them over. So I'm going to move my 7 over to the other side. So I get x squared plus 6x minus 7 is equal to 0. Now I'm ready to factor. This time I have a negative for my last term, so I know I've got different signs. I think about what could I multiply to get 7? Well, it's really just 1 times 7. But I want them to subtract, because they're going to have different signs, to give me 6. Well, I want a positive 6, so that means I need my bigger number to be the positive and my smaller number to be my negative. Now I go ahead and use my zero products property. X plus 7 is equal to 0. X minus 1 is equal to 1 is equal to 0. And I solve them and get x is equal to negative 7. And I get x is equal to 1. So let's check them real quick. Plug them back into our original equation. So negative 7 squared plus 6 times negative 7, is that going to be equal to 7? Well, negative 7 squared is 49, plus a negative 42. Well, that is 7, so it worked. For my other one, I'm going to plug in 1. So 1 squared plus 6 times 1 equals 7. 1 squared is 1, plus 6, 7 is equal to 7. So we're just factoring our polynomials, but we're just taking it one step farther by finding the actual solutions to this equation. All right, so let's try 3, 2, and 3 here. So I'm going to, oh, sorry, I just did those on the other screen. So let's do the 3 at the bottom of the page. So I'm going to start by factoring my expression. They're both positive, so I know it's going to be x plus for both of them. What's going to give me 42? Well, I could do 1 and 42. I could do 2 and 21. I could do 3 and 14. I could do 6 and 7. But I want to know which one's going to add to give me 17. Well, that's going to have to be my 3 and my 14. But that's still equal to 0. So to solve, I'm going to set each one equal to 0. So if x plus 3 is 0, x must be negative 3. If x plus 14 is 0, x must be negative 14. Okay? So those are my two solutions to that equation, negative 3 and negative 14. Next one, got a little bigger numbers. Again, p times p is going to give me p squared. I have a negative for my last term of subtracting, so I know I'm going to have opposite signs. Now I've got to figure out, okay, what would I multiply to get 84? But they're going to subtract, because they're going to have different signs, to give me 5. So I need numbers fairly close together. So think about some of the different things that you could multiply to get 84. I could do 1 and 84. I could do 2 and 42. Okay? But the one that is going to work for me, because I want them to be close to each other, is 7 and 12. When I subtract 7 and 12, I get 5. When I multiply them, I get 84. So I want a positive 5p left in the middle. So when I combine those terms in the middle, I want the positive number to win. So I want the 12 to be a positive and the 7 to be my negative. Then I go ahead and set each of them equal to 0 and solve them. So p is equal to negative 12 and p is equal to 7. All right, one last one and then it's going to be your turn. Notice this time I have a coefficient in front of x squared, so I'm going to try to get rid of that by factoring it out. So I can factor that out and get k squared plus 3k minus 54. Now I try to factor my polynomial. So I'm going to have a k and a k. I have a subtracting at the end, so I know they're going to have opposite signs. I want two numbers that multiply to give me 54. So I could have 1 and 54, 2 and 27. We could do 3 and 18. Let's see, what else can we do? We can do 6 and 9. So I need a combination of numbers that multiply to give me 54, but have a difference of 3, because they're going to get subtracted. One's going to be positive, one's going to be negative. Well, 6 and 9 are the ones that are going to give me a 3 for a difference. I want a positive 3, so I know my bigger number has to be the positive. So the 9 is going to be my positive, and the 6 is going to be my negative. Now I go ahead and solve them. K plus 9 is equal to 0, and k minus 6 is equal to 0. So I subtract my 9 and get k is equal to negative 9. I add my 6 to solve it, and I get k is equal to 6. So my two solutions are k is equal to negative 9 and k is equal to 6. When we solve it, we don't need to do anything with the 2, because the 2 is just going to get multiplied times these terms. So as long as I turn one of those terms into a 0, even multiplying by 2, I'm still going to get 0 for an answer. All right. So now I want you to try 4 of the problems on the next page for yourself. Rewrite them if you need to move terms all to the same side. Check to see if there's a greatest common factor I can factor out. Then factor the expression into two binomials, and then set them equal to 0 and solve for your solutions. See how you do.